Hi, my name is Aaron Goldsmith. I'm a tutor for actuaryexamtutor.com. We'll be reviewing the calculus necessary for the P exam. If you've ever taken calculus, you know the whole subject is quite fond of this little letter d. We put a little letter d in front of an expression to mean to take a small difference of that expression, or a differential. We use differentials to compare quantities that we can't change to quantities that we can change. This comparison, or the ratio of df to dx, is called the derivative of f with respect to x. You can make it clear that f depends on x by pulling this down and putting an x in parentheses for the function notation of a function, or you can abbreviate and put a prime above f. These all say the derivative of f with respect to x. It's defined for some value x0 very close to x to be the difference of the f values at x and x0 divided by the difference of the x values. If x is a measure of time, this you can think of as the instantaneous rate of change. So x0 is just an instant away from x. And so you're looking at how the values of f change in that instant divided by how much time passed. So you get a rate. It's important to know that derivatives of functions distributes over the plus sign and constants pull out. So the derivative of this combination of functions is a combination of derivatives. The most important function we'll take the derivative of will be a power function like x to the power n. And to track the change of x to the n, we can take h to be a very small number. So I use this notation double less than to mean that h is much less than 1. And I assume that h is going to be positive. So we want to track the change in x plus h to the power n. I used the rule from the last video on how to expand products of sums. And the most important term in this expansion is going to be when we multiply by x every time. So x to the power n, because the moment you multiply by h, it becomes much smaller. The next term that we care about is going to be when we multiply x n minus 1 times and only have one h. But there are going to be n ways to do that, n terms to pick the h from. So we have n times x to the n minus 1 and then times h. And then we'll get some more terms with more and more h's. If you put this into the function, the definition for the derivative, we're going to subtract out x to the n and then divide by the change in the x's. So the x to the n cancels out, and after you subtract that off, you divide by h. Then you have n x to the n minus 1 plus a bunch of terms with h in them. So as h gets very small, those get small and small all the way to 0. You end up with the rate of change being n times x to the n minus 1. This is called the power rule. We have a couple rules on how to take derivatives of combinations of functions that we already know how to take derivatives of. So the product rule is how to take derivatives of products. If you look at the differential of a product, it's going to be f becomes f plus df. So changing f by a small amount, df becomes f plus df, and g becomes g plus dg. And then you take their product and subtract off the original product, fg, and divide by the small change in t. We expand this out, and you get fg, and then minus fg, that cancels out. Then you have f times dg, and df times g. So those stay. But then df times dg is going to be much smaller than any of the other three terms because it's a product of two differentials. It's going to be negligible. So when we simplify it, you get f times dg dt plus g times df dt. Well, that's the product rule. The chain rule is how to take the derivative of the composition of two functions. So if you evaluate one function and then put it in the input of another function, if g is put into the input of f, then this function, you take the derivative of f with respect to the input of g, and you get the derivative of f with respect to the function g times the derivative of g with respect to its input t.